We're going to talk about power in this video. So power is very related to work, which was in the previous video. So now work, power, energy, we're hitting the second one. So power. Power is the rate at which work is done. And way back beginning of the semester, we talked about what a rate is, and rate is something over time. It's how quickly something happens. And so power is how quickly work happens. So power, which is capital P, is equal to work, which is W, divided by time. So work over time. So how much work is done per unit time. Because work is force times distance, then power will be force times distance over time. Now you'll see these two equations on the equation sheet, but this is just showing you work in the equation, FV over T. The metric unit for power is the watt, and this is the same watt as in your light bulbs. So light bulbs have a watt as in how much electrical work is done per unit time. So higher wattage bulbs push more energy, transfer more energy through the bulb in a given amount of time. Same idea here. It's how much work is done, how quickly you apply a force over a distance in a given amount of time. The English unit of power is the horsepower, and this is the horsepower you think of with cars. You will not need to know this conversion, but just to kind of give you an idea in terms of light bulbs and what a horsepower is, 1 horsepower is equal to 750 watts. And this unit did come from what it looks like it did. 1 horsepower is the amount of power 1 horse could generate. So 2 people each weigh 200 newtons and climb a flight of stairs that raises them 10 meters vertically. So the first question is, who did more work? Well, if we have 2 people who have the same weight, then this weight is how much force they had to move, or how much force they had to apply to move. So this is our force. And they each go 10 meters, which is our distance. Since both are the same, they do the same work. If person A climbs in 20 seconds and person B climbs in 40 seconds, who generated more power? Well, since power is work over time, then that means more power is generated by the person that takes the least amount of time. So who generated more power? Person A. Less time, more power. If the denominator increases, this decreases. If the denominator decreases, this increases. It's an inverse relationship. In this next concept example, we're going to look at a car that can accelerate from 0 to 60 miles per hour in half the time. So if we had one car that could accelerate from 0 to 60 in a certain amount of time, how would the power be different if it were half the time? So this is what kind of question? Factor. Because here we're asking for half, which of course is a change in time. Change, no units, factor question. So we're going to start with the equation. P equals work over time, so W over T. And what's changing? Well, power is changing, and half the time. So time is changing. Work is not, so we cross that out. We're left with P equals over T, and since nothing's on the top, our placeholder is a 1. So if it's half the time, half is the same as 0.5, and 1 over 0.5 gives you 2. So a car that can accelerate from 0 to 60 in half the time will have twice the power. Suppose a 40 horsepower engine can accelerate from 0 to 60 in 16 seconds. A car with 4 times more power could accomplish it in how many seconds? So even though there's a number here with units, we're still saying 4 times the power. So it's a change in power, still a factor problem. So let's use a different color. So start with the equation and circle what changes. Well, power is changing, so we'll circle that. And we want to know how these seconds change, so we'll circle that. Again, work doesn't change, so we get the same 1 over t. So now I'm telling you that the power is changing by 4. And so I want to know how time is going to change. So we need to solve for t. First thing we're going to do is multiply both sides by t. That cancels t over here. So we get 4t equals 1. And then we divide by 4. So what you're going to notice is in both of these problems, these are inverses. So time changes by half, power changes by double, 1 over 2 versus 2. In this one, power changes by 4, time changes by a fourth. So 4 and 1 over 4. So they are inversely related. So inversely related for power and time. So as power goes up, time will go down. So now let's just do a few actual examples using the equation. So these are going to be plug and chug. How do we know? 500 joules has a unit, 10 seconds has a unit, and we're asking for how much power. There's no changes involved here. So power equals work over time. So power is 500 joules over 10 seconds, which gives us 50 watts. Power is in watts. All right, so in the second example, we have 50 joules of work in 4 seconds. So again, both numbers have units, so we're going to do just plug and chug. So power equals 50 joules over 4 seconds. And here I happen to use units, you don't have to. And that gives you 12.5 watts. So another example here, you exert 50 newtons of force, to push a box 4 meters in 15 seconds. So 50 newtons of force, well, that's F. To push a box 4 meters, that's D. And then 15 seconds is time. All right, so we have power equals work over time, but we don't have work. What we do have is force and distance. And we remember from the previous video that work is force times distance. So we can find work by doing 50 times 4 to get 200 joules of work. Now we can plug it in. So P equals 200 joules divided by 15 seconds, and we get 13.3 watts. So for this example, we had to first find work, and once we found work, then we could find our power. So in this question, it says person A weighs 230 newtons and climbs 6 meters in 10 seconds. Person B weighs 100 newtons and climbs 10 meters in 10 seconds. Who generated more power? Well, let's divide it up. So we have A and we have B. So for person A, we have this weight. Weight is a type of force. This person is also going 6 meters, which is our distance, and does it in 10 seconds. which is our time. So I'm going to do a shortcut here now. So work over time. So power is force times distance over time. So we get 230 times 6 divided by 10. So for power here, we get 230 times 6 divided by 10, which gives us 138 watts. Now let's do person B. Person B, I'm just going to start here, force times distance over time, weighs 100 newtons, that's the force, climbs 10 meters, that's the distance, in 10 seconds, which is the time. So 100 times 10 divided by 10 gives you, well, hey, those cancel, 100 watts. So person A generated more power.